Right now, expanding outward from Earth at the speed of light, there is a sphere, not a physical object, a wavefront, an expanding shell of electromagnetic radiation traveling through the galaxy in every direction simultaneously, growing by 1 light-year every year, carrying encoded within it the entire history of human broadcasting. At the outer edge of that sphere, the first radio signals powerful enough to escape Earth's ionosphere, generated in the early 20th century. Guglielmo Marconi's transatlantic transmissions. The first intentional broadcasts. The first structured signals that any civilization sufficiently technologically advanced could, in principle, detect and identify as artificial. The sphere is currently approximately 100 light-years in radius. 100 light-years sounds like a vast distance. By human standards, it is incomprehensible. By the standards of the galaxy, it is nothing. The Milky Way is 100,000 light-years across. Our expanding bubble of signals has penetrated approximately 0.1% of the galaxy's diameter. But within that sphere, there are stars. Real, cataloged, studied stars. Approximately 15,000 of them. Some of them with known planets. Some of them with the right properties to host life. Some of them, statistically, almost certainly with planets that have been in the right condition for biology for longer than Earth has existed. Somewhere in that sphere, or perhaps just outside its edge, where signals sent decades later are now arriving, there may be something listening. And if it is, it has been receiving us for some time now. The history of what we have been sending is worth understanding before asking who might receive it. The first radio signals powerful enough to escape the ionosphere and enter interstellar space were generated in the early 1900s. The exact date is debated. The ionosphere reflects lower frequency signals back to Earth, and only higher frequency transmissions escape into space. The first reliable transmissions at frequencies capable of escaping were produced in the 1920s and 1930s as broadcast technology matured. Adolf Hitler's opening address at the 1936 Berlin Olympics is often cited as the first television broadcast powerful enough and at the right frequency to have leaked into space. It is one of the first structured, high-power signals that would be traveling outward from Earth, now approximately 90 light-years away, crossing the spaces between stars in the constellation Vela. This image, Hitler's voice, one of the first human transmissions crossing interstellar space, contains an irony that no fiction writer would dare use. Subsequent decades added radar pulses, television broadcasts, FM radio, military communications, and eventually deliberate transmissions aimed at the sky. The entirety of 20th century broadcasting, every radio program, every television show, every military radar scan, every cellular tower signal that leaked into space, is encoded in that expanding sphere. Not clearly, not coherently. The signals weaken as the inverse square of the distance. By the time they reach the nearest star, they are enormously diluted, a faint whisper against the background noise of the cosmos, detectable only by an instrument far more sensitive than anything we have built. But present, the question of detectability is more complicated than it first appears. Early analyses of the detectability of Earth's radio leakage tended toward pessimism. The signals are weak at interstellar distances. A civilization receiving Earth's broadcast sphere from the nearest star system, Proxima Centauri, would need a radio telescope far larger than anything we have built to extract a coherent signal from the background noise. But the pessimistic analysis assumed passive leakage, the unintentional escape of signals designed for terrestrial use, not optimized for interstellar communication. The picture changes for intentional transmissions. In 1974, the Arecibo radio telescope in Puerto Rico was used to send a deliberate message toward the globular cluster M13, approximately 25,000 light-years away. The Arecibo message was a binary encoded pictogram containing basic information about humanity, our position in the solar system, our biochemistry, the structure of DNA, a representation of a human figure. It will not arrive at M13 for approximately 25,000 years. But the Arecibo message was a demonstration of intent rather than a serious communication attempt. M13 is so far away that any reply would take 50,000 years round trip. The message was a proof of concept, a demonstration that we could, if we chose, produce a signal detectable at interstellar distances. More practically significant are the radar transmissions associated with planetary defense and astronomical research. The Arecibo and Goldstone radar systems, used to map near-Earth asteroids and the surfaces of planets, produced some of the most powerful directed radio signals Earth has ever generated, power levels that, aimed at a nearby star, would be detectable by a civilization with technology comparable to our own. We have not aimed them at nearby stars. We aim them at asteroids and planets. But the directionality means that any star that happened to lie along the radar beam's path received a signal far stronger than any broadcast leakage, a brief, powerful pulse that a sufficiently attentive civilization could detect. How many times this has happened, to which stars, is a calculation that has been made informally but not comprehensively. Within 100 light-years of Earth, the population of stars is diverse. Approximately 15,000 stars fall within the current broadcast sphere. They range from massive blue giants that live for only millions of years to dim red dwarfs that burn for trillions. Some are single stars. Many are binary systems. A significant fraction have confirmed planetary systems. The Kepler and TESS missions have found planets around stars throughout this volume of space. Several nearby stars deserve specific attention. Tau Ceti is approximately 12 light-years from Earth. It is a sun-like star, slightly smaller and less luminous than our Sun, with a known system of planets, several of which orbit in or near the habitable zone. It has been a target of SETI searches for decades. Signals transmitted from Earth in the 1920s reached Tau Ceti approximately 12 years after they were sent. If anyone at Tau Ceti received the earliest human broadcasts and responded immediately, their reply would have reached Earth approximately 24 years after the original transmission. Around 1950. We were not listening in 1950. Epsilon Eridani is approximately 10.5 light-years away, one of the closest sun-like stars to Earth, young by stellar standards, known to have at least one planet. It receives our signals approximately 10.5 years after they are sent. Signals sent in the 1910s arrived there in the 1920s. If a response was sent immediately, it would have arrived in the 1930s. We were not systematically listening in the 1930s. The pattern reveals something uncomfortable. We have been broadcasting for approximately 100 years, but systematic listening, organized, comprehensive search efforts capable of detecting a reply signal has existed for only about 60 years, since Frank Drake's Project Ozma in 1960. Any civilization within 6 light-years that responded immediately to our earliest broadcasts would have had its reply arrive before we were capable of detecting it. The Voyager probes carry a different kind of message. Voyager 1 and Voyager 2, launched in 1977, each carry a golden record, a 12-inch gold-plated copper disc containing sounds and images intended to convey something of Earth and humanity to any civilization that might encounter the spacecraft. Music from multiple cultures, greetings in 55 languages, the sounds of surf, wind, thunder, and animals. A map showing the location of Earth relative to 14 pulsars, whose characteristic pulse periods allow any recipient to triangulate our position in the galaxy. Voyager 1 is currently more than 25 billion kilometers from Earth, around 170 astronomical units. roughly 4 times the distance from Earth to Neptune. At its current speed, it will take approximately 40,000 years to reach the nearest star system. The Golden Record will almost certainly never be found. The probability of a spacecraft drifting through interstellar space, without propulsion, on a random trajectory, encountering another civilization or being detected by one, is extraordinarily small. The galaxy is vast. The spacecraft is tiny. But the record represents something different from the broadcast sphere. It is not an accidental leakage or a technical demonstration. It is a conscious, deliberate act of communication, a physical artifact encoding the message that we know we exist. We know we are not alone in a mathematical sense, and we want to be known. The Voyager record was created in a period of weeks in 1977 under the direction of Carl Sagan. The people who made it understood that it was almost certainly a message in a bottle thrown into an ocean so vast that the odds of it being found were essentially nil. They sent it anyway. The question of what might have hurt us requires confronting what we know and do not know about the distribution of life in the galaxy. We know that the chemical building blocks of life are abundant throughout the galaxy. Amino acids, the molecules from which proteins are built, have been found in meteorites. Complex organic molecules have been detected in interstellar molecular clouds. The elements necessary for life as we understand it, carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, are among the most common in the universe. We know that planets are common. The Milky Way contains more planets than stars. Most stellar systems appear to have planetary companions. A significant fraction of those planets orbit at distances where liquid water could exist. We do not know whether life arises wherever conditions are suitable. We do not know whether simple life routinely evolves into complex life. We do not know whether complex life routinely develops intelligence and technology. The Drake equation, formulated by Frank Drake in 1961 as a framework for estimating the number of communicating civilizations in the galaxy, quantifies this ignorance precisely. It is a product of several terms, most of which we cannot reliably estimate. The final term, L, the average lifetime of a technological civilization, is the most uncertain and in many ways the most consequential. A civilization that exists for 100 years before destroying itself contributes almost nothing to the galactic communicating population at any given time. A civilization that exists for 1,000,000 years contributes enormously. We have existed as a technological civilization capable of interstellar communication for approximately 100 years. We do not know if that is typical. Here is the specific discomfort that the broadcast sphere creates. We did not choose to announce our presence. The signals that left Earth in 1920 and 1930 and 1940 were not sent with interstellar communication in mind. They were radio programs, radar sweeps, military communications, television broadcasts. They escaped into space because the physics of electromagnetic propagation does not respect the boundaries we intended for our signals. We announced our presence to the galaxy before we knew the galaxy well enough to decide whether announcing our presence was wise. The METI debate, the debate over messaging extraterrestrial intelligence, the deliberate transmission of signals intended for potential alien recipients, has been ongoing in the scientific community since the 1970s and has intensified since the 2000s. The debate is not about whether to continue the accidental leakage of broadcast signals, which cannot be stopped. It is about whether to send deliberate, targeted, high-power messages aimed at specific stars, whether to amplify our announcement beyond the background noise of passive broadcasting. Proponents argue that any civilization capable of responding is almost certainly far more advanced than us. They would have had billions of years of head start, and that the risk of contact is lower than the benefit of finding evidence that we are not alone. Opponents, including, famously, Stephen Hawking, argue that signaling our presence to an unknown civilization is reckless, that we cannot know the intentions of a civilization capable of interstellar communication, that the history of contact between unequally advanced civilizations on Earth is not encouraging. Both positions are taken seriously by serious people. The debate has no resolution, and while it continues, the broadcast sphere expands. Within the sphere right now, expanding outward at the speed of light, is a specific piece of audio, approximately 57 light-years out from Earth, in the direction of the constellation Canis Major, roughly in the vicinity of the star cluster NGC 2362. The broadcast front carrying the first moon landing is now passing. July 20th, 1969. Neil Armstrong's voice. That's one small step for man, one giant leap for mankind. That transmission left Earth in 1969. It has been traveling for 57 years. It is 57 light-years from Earth right now, somewhere in that expanding wavefront. Encoded in the electromagnetic noise of a broadcast designed for human television sets is the sound of the first time a member of our species stood on a world other than our own. Any civilization within 57 light-years with the technology to detect it has received it. Most of the roughly 15,000 stars within our broadcast sphere are far enough away that they are receiving our early century broadcasts, static, noise, the first crude radio signals of a species that had not yet split the atom. The most distant ones, at the edge of the sphere, are receiving signals from approximately 100 years ago. None of them are receiving signals from now. The outer edge of what we have sent is a century behind us, and any reply from any civilization at any distance within that sphere is a round trip away. We have been talking for 100 years. Not intentionally, not coherently, not with any expectation that anyone was listening, but consistently, continuously. Every radio tower, every radar system, every television broadcast, every cellular network, every military communication that leaked the right frequencies has added to the sphere, added to the announcement. Here, 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 we are here. The sphere is approximately 100 light-years in radius and growing by 1 light-year every year. In 10 years, it will contain a few more stars. In 100 years, significantly more. In 1,000 years, it will have reached stars currently invisible to the naked eye, stars we have not yet individually cataloged, stars that may have planets we have not detected. Whether any of those stars host something capable of listening, something that will receive our accidental century of broadcasting and understand it as a signal from a living world, we do not know. Whether such a civilization would respond, whether we would detect the response, whether we would know how to interpret it if we did, whether the response would be already on its way, already crossing the space between some star and our receivers, arriving in a year or a decade that has not yet come. All of this is unknown. The sphere expands, the signals travel, and somewhere in the galaxy, across a distance measured in light years and a time measured in decades, there is either nothing listening, or something that already knows we are here, has known for some time, and has not yet decided what to do about it.